Welcome to Math Olympiad problems. After a long time and with a very long break, I'm coming back to the Math Olympiad problems. I hope these are all helpful for you. Okay, this is a very good collection of problems from different Olympiads, mostly from IOQM and practice of IOQM, but I have also collected from other Olympiads. Okay, let's get into this. So as I always say, this is useful for class 8th to class 12th. Class 8th, it will may look tough, but 9th and 10th students should be able to do all these problems. Okay. And 11th and 12th students definitely should do. Okay. They should not think that these are tough. Let's get into the problems. If number of different triangles formed by integer angles, n is n, what is n? Okay. If n number of different triangles are formed by integer angles, all are integer angles. Okay. There is no fraction in this. What is n? Okay. So we can solve this problem in two ways. One is the simple Math Olympiad normally gives such problems for class 8th and 9th, 10th kids for counting actually. Okay. Kind of counting problems. Okay. And if you are good in functions and number theory, you can also solve using functions. Let's do both ways. Okay, first the counting method. Okay, ABC are the angles of triangle. Okay, we know that A plus B plus C is 180. So A comma B comma C belongs to 1 to 179. Okay, it cannot be 0, it cannot be 180. Okay, so this is where it's possible. So how many number of combinations are possible with this range A comma B comma C ranging from 1 to 179? Okay, so number of triangles formed by above information is 179C2. Okay, which is 179 into 178 divided by 2 factorial. This many combinations are possible. Okay, A can choose any of the 179 combinations. Okay, B can choose the remaining 178. Okay, so these are the maximum number of possibilities. Okay, now let's get into the next now. Okay, to remove the repetition, basically this 2 factorial is there. Okay. Now, we know that there is one case. First, we will count only those triangles where angles are different. Okay, angles are not repetition. Okay, so we know that one condition which is repetition very easy. A equal to B equal to C, which is 60 degrees. This is only one case is possible. Okay, so one condition we will remove. Second condition is if two of the angles are same. If two of the angles are same means A equal to B and not equal to C. Okay, there are total 89 cases. How did we get these 89 cases? Okay, yeah, let me show you this table here. Okay, if angles are ABC, C is 178 because A equal to B, right? And A and B are 1 comma 1. Then this is 178. 2 and 2, then 176. So similarly, you will go up to 89 and 89 and C will be 2 degrees. How many cases are there total? 89 cases actually. Okay, total are 89 cases. But 60 equal to 60 equal to 60 is one of this case, which already we counted here, one, right? So there are only 88 cases. Okay, if A equal to B and not equal to C, there are 88 cases. Similarly, A is not equal to B, but B is equal to C, and A is equal to C, not equal to B. Okay, basically, uh, other two angles are same. Here also you'll get 89 cases each. Okay, so total number of cases what we counted so far is 179C2. All the possibilities minus repetition are 3 times 88 minus 1, which is 60 degrees each. Okay, divided by 3 factorial. Why we are dividing with the 3 factorial? Okay, it can be A, B, C, it can be any order, right? So order we are removing, so 3 factorial. Now this is the number, if I calculate, it is 2611 unique angled triangles are there. Okay, these are the unique angled triangles. Now I just need to add, first is when two angles are equal, which is 88, when three angles are equal, which is 1. If I add all this one, we'll get 2700. This is the answer. This is a very, very simple counting problem. Okay. Only thing is you should have all the conditions in place properly and don't do mistakes. Okay. So hope this is you understand this by the counting method. Now let's do this problem with functions and little bit number theory. Okay. ABC are angles of triangle. A is less than or equal to B or less than or equal to C. This is what our assumption. Okay. Now let B is equal to A plus T, because we are assuming A is less than or equal to B. So let B equal to A plus T. T can be greater than or equal to 0. Correct? This implies C is equal to 180 minus A plus B, which is 180 minus 2A minus T. In the place of B, I am substituting A plus T. Hope you are clear till that point. Okay? Now, next. T is maximum when B is equal to C. How can we say this? Okay, let's see. First, T is maximum here if A is smallest, correct? That is one condition. How much it can go? Maximum it can go is, let's say if A is 1 degree, T can be B minus 1. Okay, but what could be the maximum of B? Okay, maximum of B is C. Okay, it cannot be more than C, right? B cannot be more than C. So T is maximum when B is equal to C and A is minimum. These are the two conditions, right? So you take the condition B equal to C. If B is equal to C, I can rewrite this C equal to 180 minus 2A minus T. I will write it as, okay, B is equal to C, right? So B is nothing but A plus T, so which is C. So A plus T equal to 180 minus 2A minus T. From this, I can derive my equation for T, which is 180 minus 3A divided by 2. Okay? This is very important equation to note. Okay, this is my function actually. Okay? This is my function of A. I am defined my triangle, okay, in terms of function of A, only one angle. Okay, so and we know that T is between this value and T is greater than or equal to 0, right? So f of A is function of A is equal to 1 plus 1 plus, this is the a maximum integer function, 180 minus 3A by 2 max integer. Okay, you cannot get the decimals because we are looking for the integers, and whatever is missing, I'm adding that plus 1 here. Okay, now how can I convert this function into a simple integer function? Once I convert it, I am done. I get my answer. Okay, because I have a function with only one variable. Only thing is this is not exactly a integer function, right? Division I can get a decimal. The decimals are missing here. Okay. Now how can we do that? We consider angle A as even and odd. That's it. That's a very simple way. For even A values, which is A equal to 2k, if I take, this will become, okay, 91. Okay, this is 90. 180 by 2 is 90 minus 3k, because A is 2k, right? 3k plus 1. So 91 minus 3k. And for odd values of A, it will become A is equal to 2k minus 1, and it will become 92 minus 3k. Okay, you substitute, you will see. Okay, you will get 92 minus 3k. Now I have a even function, I have a odd function. So what is my total combined function? Combined function is simple. Sum of these two, 183 minus 6k. And k is ranging from 1 to 30. How? If it is 1, I have 183 minus 6. If it is 30, I have 180 minus 180. 183 minus 180, which is 3 degrees. I cannot go to 31. K cannot be 31. 31 means it will become negative. Right? So this is my range of k. This is my function. I have everything. I just need to do sigma now. Right? All possible triangles are, number of triangles is equal to sigma. K is equal to 1 to 30. 183 minus 6k, which is nothing but 2700. Okay. Hope you understand the second method also. First method is definitely easy. Yeah. You can practice more, because every time you will get at least a problem with counting method, at least a problem in Olympiad, IOQM also. Yeah. Next, if the altitudes of the triangle are 10, 12, and 15, then what is its perimeter? Okay, this is a simple problem. Only thing is you should know how, when altitudes are given, how to get the perimeter or area. Okay. So let 10, 12, and 15 are the altitudes onto A, B, C. These are the sides A, B, C. Then we know that area of the triangle is 10A by 2, 12B by 2, or 15C by 2, which is simplified. Okay. If delta is the area, then it will become A is equal to delta by 5, B is equal to delta by 6, C is equal to 2 delta by 15. Okay. Now we have a relation between area and each side. Okay. Now we also know that area can be derived from semi-perimeter, right? So S is equal to, semi-perimeter is equal to A plus B plus C by 2, which is, if I add these three values, what I will get is delta by 4. Okay. Now delta, my area can be defined as square root of S into S minus A into S minus B into S minus C, which is nothing but this expression here. If I simplify this, what I will get is delta is equal to 240 by square root of 7. This is what I get. Okay, 240 by square root of 7. This is my delta. Then if I substitute here, I'll get my S area, this one semi-perimeter. Then from there I can get perimeter, right? So A plus B plus C is nothing but 2S. S is nothing but delta by 4. So 2s is delta by 2. So which is equal to 220 by square root of 7. Okay, this is the perimeter of the triangle. Next, a sequence of natural numbers is constructed by listing the first four, then skipping one. Okay, listing the next five, skipping the two, listing six, skipping three, and so on. Okay, on the nth iteration, listing n plus 3 and skipping n. Okay, the sequence begins with 1, 2, 3, 4, then skip 5, 6, 4, 6, 7, 8, 9, 10, then skip 11 and 12, then 13, and so on. Okay, what is the 500,000th number in the sequence? Okay, this came in AMC. It looks complicated but very easy if you put it in proper order. Okay, so what we will do is we will construct a triangle with this triangle or pyramid, whatever you can call, with this number. Okay, and then see how easy this problem is. Okay, let's put the numbers in pyramid of rows. Okay, so 1, 2, 3, 4 are in the first row. There are total 4. 6, 7, 8, 9, 10 are in the second row. 5 is skipped here, right? 5 are in this row. Then 11 and 12 are skipped. Then 13, 14, 15, 16, 17, 18, 6 are in this row, 7 are in this row, and so on. Okay, this is how the number pyramid is constructed, right? Once we know this, these numbers are in AP. 4, 5, 6, 7, dash, 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 these are in AP. So now I need to find 500,000th number, where it comes basically. Okay, which row it comes. Okay, so that is simple. We have a AP equation, right? A is equal to 4, starting with 4. B is 1, every row is incremental by 1, and I need to find out 500,000, which is greater than or equal to sum of all integers in this row, okay, which is n by 2 into 2a plus n minus 1 into d, which is equal to n by 2 into n plus 7. Okay, if I substitute a and d values here, this is what I get. Now the minimum value, either I can just take it, solve this equation inequality, I will get the nearest integer. Okay, so that is for n is equal to 996. This is the number I get. Okay, 997, it will exceed 500,000. Okay, so that means the number 500,000 is in 997th row. Correct? 997th row and 506th number. 506. If I add 506, I will get 500,000 to this. Right? Now I know where is which row it is. Now I need to check how many numbers are skipped until that row. Right? So for each row, the numbers skipped are also in AP. In first row, one number is skipped, second row, two are skipped, third or three are skipped, right? So 1, 2, 3, dash, 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 up to 996 I should take. So sum of 996 is 996 by 2 into 997, which is nothing but 496,506. Okay. Now I know that this many numbers are skipped. Okay, so I should add to this number and then 506. So my number is 500,000th number is, one is this number up to this row. How many numbers? These many numbers are skipped and I need extra 506 because in 997th row, 506th number is what I'm looking at. So which is nothing but 996,506. This is the answer. Thank you. Next. Yeah, this is a very good JEE mains question and very potential to come in Olympiad problems. Okay. The question is find out the coefficient of x power 7 in given expression 1 minus x plus 2x cube whole power 10. Okay, this expression might change. They may give something else, but the procedure is same. Okay, so how to find a given x power n from a given polynomial power? Okay, so this is the question briefly. So there is a trick for this one actually, very easy. Okay, if you solve it, you will actually end up in the same thing. Okay, so the shortcut is for all such questions where you have in this format a plus b plus c whole power n and you are supposed to find some specific term. Okay, what you will do is first find the powers ijk such that I plus j plus k equal to n. Okay, we are finally trying to find out x power 7, right? Here n is equal to 7. So I need to make sure that my I, j, k are equal to sum of I, j, k is equal to n. And then this is my term a power I, b power j, c power k, and it will have some coefficient. What is the coefficient? Coefficient is here, okay, given here. Sigma of all such I plus j plus k can be multiple possibilities, right? Need not be only one possibility. Okay, example, if I take example 7, you can get it from 1 plus 3 plus 3, 2 plus 2 plus 3, right? Like that. 0 plus 1 plus 6, like that. Okay, so the sum of all such possibilities, you sigma those terms, okay, with n factorial by I factorial, j factorial, k factorial, and ij, bj, I to the power of j, b to the power of j, c to the power of k. Okay, let's put it in example here. Okay, the problem here. So let's first find ij case. Okay, you need to find I plus j plus k equal to 7, right? X power 7 term is what I'm trying to find out. And first term is 1. So there is no x term. So whatever power you keep here, it doesn't make any difference, right? Only j and k makes you the difference. So let's take x power 4 here, okay, and x cube here, right? So that is power 1. So 4 plus 3 will be 7. X power 7 term you got. Remaining how many terms are there? Because total should be n. So 4 plus 1 is 5. So n is 10. So 10 minus 5, which is 5 first terms. Okay. 5 product of the first term to the power of 5. Okay. Then second option I have is j can be 1. J can be 1, x power 1, and k can be 2x cube whole power 2, which is nothing but x power 6. X power 6 plus x power 1, which is x power 6 into x power 1, which is x power 7. Again, this is the term we got. So there I am using only 3 terms here. So other 7 terms are first terms. Okay. Similarly, other option I have is everything x power 7 is from second term and no contribution from the third term, and the remaining 3 are from the first term. Okay. So these are the only 3 possibilities I have. These are my ij case. Okay, now just write the sigma n factorial by I factorial, j factorial, k factorial into 1 to the power of I, which is anyway 1. So I will ignore this. Minus x whole to the power of j, 2x cube whole to the power of k. So the 3 terms are here. Okay, n factorial by 5, 4, 1, right? First one is so 5 factorial divided by 5 factorial, 4 factorial, 1 factorial, and then minus x to the power of 4, 2x cube whole to the power of 1, plus second one is 712. So 712, okay, to the power of 1. 1 to the power of 7 I am ignoring. This is 2. Similarly, third one, which is only x power 7. Okay, minus I kept here. So it is actually minus x whole power 7. So minus is here because it's odd power. Now just you have to simplify, calculate these terms. Okay, these terms will become 960 x power 7 because the quotient is 960. This is the quotient. Okay, so all these kind of problems you can solve using this. This is useful for IOQM as well as JEE mains. Okay, next. Find the sum of all positive solutions of 2 cos 2x multiplied by 2 cos 2x minus cos 2014 pi square divided by x, okay, which is equal to cos 4x minus 1. Okay, so now all such problems I keep saying before also in Olympiad as well as in engineering entrance practice videos. Whenever you see cos A and cos 2a, you convert 2a into a. Okay, so here cos 4x will convert into cos 2x terms. That's simple. Cos 2a equal to 2 cos square a minus 1. So I'll replace it to, I'm just multiplying the, taking the product inside the bracket. So 2 cos square 2x minus 2 cos 2x cos 2014 pi square by x, which is equal to 2 cos square 2x minus 2. 2 cos square 2x, 2 cos square 2x gets cancelled. So I am left with actually cos 2x into cos of 2014 pi square by x, which is equal to 1. Now I know that cos range is minus 1 to 1. So this is possible only if each of these terms is either 1 or minus 1. Each of them should be either 1 or minus 1. There is no other possibility here. So just take case 1. Both are 1. So cos 2x equal to 1, which means 2x is equal to 2k pi, okay, which is even pi's basically, or x is equal to k pi, where k belongs to natural numbers. Okay, now other one is 2014 pi square by km, x is nothing but km, right? X is km, okay, which is equal to 2014 pi by k. This should be even, correct? This should be even, which implies pi, which implies 2014 by k should be even, right? Pi is anyway fixed number, so 2014 by k should be even. When this will be even? Okay, if you take 2014 product factors, 2 into 19 into 53. So k can be either 1 or 19 or 53 or 19 into 53. Okay, you cannot, k cannot be 2, right? K cannot be 2. So only then it will be even integer. So which means that x is equal to pi, 19 pi, 53 pi, and 1007 pi. 19 into 53 is 1007. Okay. So this is my case 1. My case 2 is both are minus 1. Okay. If cos 2x equal to minus 1, which means 2x equal to k pi or x is equal to k pi by 2, where k is an odd integer. K is only odd integer. Only for odd numbers, this will become minus 1. Correct? So, second one is 2014 pi square by k pi by 2, because x is k pi by 2, which is equal to 2 into 2014 pi by k. This should be odd pi. Okay? This should be odd pi. When it will be odd pi? Okay? 2 into 2014 by k should be odd. Okay? This is possible only if k is equal to 4. Only if k is equal to 4. Okay? Because there is a 2 here, there is a 2 here. So 2 into 2, which is 4, should be cancelled by 4. So k should have minimum factor as 4. Only then it is possible. If k is 4, then k pi by 2 will become 2 pi. Okay, 2 pi means you will not get minus 1. So this is not a possible solution. Okay, both are minus 1 is not a possible solution. There is no solution possible with case 2. So the answer is sum of all positive solutions they asked, which is 1080. Okay, you add up all these things, you will get 1085. Okay, hope you understand this. Next, this is a very good remainder theorem problem. Let's see how to do this. If the number 2017 is a prime, okay, it is given as a prime, that means it has something to do with the prime property, right? Let S is equal to sigma k equal to 0 to 62 2014 C k. Okay, this is combination, right? Permutation and combination. C. This is C. Okay, 2014 C k, which is nothing but 2014 factorial divided by 2014 minus k factorial into k factorial. Okay, what is the remainder when S is divided by 2017? Okay, so you need to understand, since 2017 is a prime, up to 2017, whatever number is there, you will get the remainder same, right? So that's why clearly mentioned 2017 as prime. So you don't need to do cross check whether it is a prime or not. Okay, let's first you take the given expression, which is sigma k equal to 0 to 62, which there are 63 terms. Okay, 2014 ck modulo 2017. This is congruent to sigma 2014 ck. I can write it as 2014 into 2013 into 2012 up to 2014 minus k plus 1 divided by k factorial. This is the definition of 2014 ck. Okay, modulo 2017, I kept it as is. Now, if you see, I can take this modulo to the individual numbers and multiply the reminders. Okay, the remainder 2014 modulo 2017 is minus 3. Next is minus 4, minus 5 up to minus 2 minus k divided by k factorial modulo 2017. This is again congruent to, if I take minus common, minus 1 whole power k, then I am left with 3 into 4 into 5 up to 2 plus k divided by k factorial modulo 2017. Okay. Now it is very simple. I can write this as sigma minus 1 whole power n k plus 2 ck or k plus 2 c2. Both are same basically. Modulo 2017. Okay. Now if I expand this one, this is easy. Okay. This is easy to expand. So this values I will get is, when k equal to 0, I'll get 1, k equal to 1, I will get minus 3, minus plus 6, minus 10, plus 15, minus 21, like this 63 terms I will get. Okay, then modulo 2017. So this is not in any proper series actually, correct? There is minus 2 difference, there is a 3 difference, there is minus 4 difference, there is 5 difference. Okay, but if you combine this, 1 I kept it as is, then minus 3 plus 6 is plus 3, minus 10 plus 15 is plus 5, minus 21 plus whatever next number will get plus 7, and so on. So you will get basically out of these 62 terms, 31 terms you will get, from 3 to 31 terms, and then 1 already there, which is total 32 terms. Okay, this is sum of odd numbers, right? Sum of first 32 odd numbers modulo 2017, which is nothing but sum of 32 odd numbers is 32 square modulo 2017. So, which is nothing but 1024 modulo 2017, which is 1024. This is the answer. Okay. Next. For some positive integers p, there is a quadrilateral ABCD with positive integer side lengths, perimeter p. Okay, p is the perimeter. Right angle set B and C, AB equal to 2 and CD equal to AD. This is the given data. How many different values of p, which is perimeter, possible less than 2015? Okay. So let's first construct the diagram ABCD. B and C right angles. Okay, AB is given as 2, AD and CD are same. So if this is X, this is also X. Then if I draw a perpendicular line AE here, it will become 2. Okay, because it's a rectangle which will be formed. Then 2 minus X. BC is, let's say it is Y, then AE also Y. Okay, now with this diagram, you can easily solve the problem. So you apply in this AED, triangle AED, Pythagoras theorem. So x square equal to y square plus 2 minus x whole square. You simplify, what you will get is y square equal to 4x minus 4. Okay. This is one very important equation to note down. Okay. 4x minus 4 is always even, which means y square also even. That means y is not a odd number. Y is always even number. Okay. So note down this one. This will actually give you a correct answer. Okay. The solution set will be reduced and you will get the correct answer. Okay. Now, x is equal to y square plus 4 divided by 4. Now, what I need is perimeter. Perimeter is nothing but 2 plus 2x plus 5. Okay. Which is less than 2015. I need to find out all possible solutions of 2x plus 2 plus 5, which is nothing but, okay, if I take 2 other side, 2013 will remain, and x I am replacing with y square plus 4 divided by 4. So if I simplify, what I will get is y square plus 2y is less than 4022. Now I will just make it into a perfect square. Y square plus 2y plus 1 is less than 4023. Okay. Or y plus 1 whole square is less than 4023. Now I know that the square root of 4023 in integers, okay, because I am always finding integer sides, right? So which is nothing but 64. This is y plus 1 is less than 64 or y is less than 63. So I can actually sum up uh, and I can say 63 solutions are possible, but note down y is even number. Okay. So y is even number means only possible solutions are only 31. Out of this 63, 1 to 63, only 31 solutions are possible. So answer is number of possible solutions are 31. Okay. Yeah. Hope you enjoyed all these problems. Next. Yeah. Thank you. That's all. These are the good collection of problems for Olympiad. Hope you like these problems. I will keep making more videos. Till then, keep doing more math. Thank you.